Next presenter is Todd Gunther. Todd works for the NTSB as an air safety investigator. He'll be speaking on safe and secure self-locking nuts, safety wire, and safety cable. Let's welcome Todd Gunther. Thank you.
Good morning. As she said, my name is Todd Gunther. I'm an investigator with the National Transportation Safety Board. And with a caveat to start off with this morning, for those of you that were expecting an airframe and power plant mechanic up here, I'm not one, okay? I'm an investigator. And what we're going to be talking about is some of the things that we found during investigations regarding the use of things such as self-locking nuts, safety wire, and safety cable. And we're also going to be talking a little bit about some of the safety aspects regarding it and how it should be properly used using FAA guidance. So the word safety is a term universally used in the aircraft industry. It's basically slang, but a lot of people will sit there and it's become a normal word that most people understand. However, if you sit there and you use like spell check or something else and you try to put it in there, it doesn't come out really well. It keeps trying to correct it, especially in autocorrect. So safety is defined as securing by various means any nut, bolt, turnbuckle, or anything else on the aircraft. The practices are not means of obtaining or maintaining torque, okay? So in other words, safety wire is not there to actually maintain the torque. The actual fastener itself is supposed to be doing that, okay? But it is a safety device to prevent disengagement of screws, nuts, bolts, snap rings, etc. due to vibration. Three basic methods are used in safetying. There's safety wire, and that can be either soft brass or steel, and in some applications you're looking at stuff like Inconel, stainless, and other materials that are temperature dependent. Okay, cotter pins and self-locking nuts are also used, and sometimes they use retainer washers and pallet nuts. The self-locking nut, and this thing is pretty cool. It's one of those things where, you know, the first time you've ever seen one, you sit there and you go, hey, what's that little plastic thing on the inside doing in there? Okay, it's an integral safety device in the construction which is intended to provide tight connections that will not come loose under vibration. And there's a wide variety of them. They've been around since the 1930s. They're generally not used in applications as subject the nut to rotation, okay, and that's another caveat because there are some that we'll talk about. However, the practice can be found in some applications where self-locking castellated nuts employed in some flight or throttle control linkages. The elastic stop nut or nylock nut appears as a basic nut with an addition in its head which allows the elastic insert to be installed and retained. And everybody's seen them. As a matter of fact, a lot of times, you know, you'll look at it and you don't even know what it is until you really look down inside the bore of the nut itself and you go, oh, wow, there's an insert in there. So originally the insert was fiber, and you can still find those guys that sit there and do antiques and warbirds. There are manufacturers that still make them with a fiber insert, okay, and they've generally been replaced by nylon though. And they're resistant to most chemicals and are not affected by normal operating temperatures. Okay, the insert is designed not to damage the bolt threads or the corrosion-resistant coating applied to the bolt. So some bolts you'll take a look at, for instance, if you look at a cadmium-coated bolt and stuff, it won't damage the coating. On a new elastic lock nut, the insert is generally a ring with a square section and an inside diameter that's smaller than the thread size of the corresponding bolt or hardware. That's how it gets its grip. So here are two examples. The top one's an example of a typical new nylon insert or nylock self-locking nut, and the bottom one is an example of a typical new fiber insert. As I said, they still do manufacturing. The nut will start easily when you go to thread it on, okay, until the elastic insert is reached. And then further rotation then forces the thread through the insert, and it deforms the insert elastically to provide locking action. So the force required to deform the insert is known as breakaway torque, and remember that term because we're going to talk about it in a little bit. At this point, the nut's secured onto the bolt with the insert providing the locking action. The accepted rule of thumb for reusing elastic lock nuts is if the lock nut can be rotated by hand, replace it. All right. Generally, elastic lock nuts can be reused, but eventually the elastic insert will take a permanent set. And then when it does that, it basically effectively mimics the threads themselves, and there's no retention capability at that point. Here's an example of a permanent set on a nylon insert self-locking nut. Now, if you look at the picture, it looks like rust, and actually that's the nylon insert itself that's been deformed to the point where it won't actually grip the bolt. And here's an example of a permanent set on a fiber insert self-locking nut. So for this reason, some maintenance manuals require that the lock nuts should not be reused, and others require that the lock nuts satisfy a minimum breakaway torque in order to be reused. And since lock nuts are most effective when the insert's deformed by the full thread, it's commonly required for at least 2 full threads to be exposed beyond the insert. So can anybody tell me what's wrong with this one? Don't everybody speak up at once, it's okay. There are no threads. We got this off the van's website. One of the posters happened to be sitting there and trying to put the nut on and kept wondering why it wouldn't engage. So that's another thing you should be looking for. It isn't just the insert itself that you should be checking the condition on. You should also be checking the nut itself because, unfortunately, manufacturing defects do happen. So let's talk about a few accidents. All right, this is what's known as a staked lock nut. All right. And does everybody remember this? The galloping goes? You'll see it, where that arrow is pointing, that's the actual trim tab coming off. And that was a P-51 Mustang airplane that collided with the airport ramp and the spectator box seating at the National Championship Air Races. The trim tab attachment screws could be rotated through the nuts by hand, and the fiber inserts were visibly worn and displayed the full thread form. And remember, as we said before, if it gets in that condition, it does not have any grip. The degraded nuts allowed the screws to loosen at race speeds, and that led to aerodynamic flutter of the elevator trim tab and the subsequent loss of the airplane. And unfortunately, the commercial pilot and 10 people died, and about 64 people were injured. Here's another one, not as spectacular, but I'm sure that the pilot thought it was. In this instance, during landing, the nose wheel separated from the nose landing gear of an air coupe. The nuts on the nose wheel bolts could be rotated by hand. There we are again with the full thread form. Only slight resistance could be felt as the bolt entered the locking portion of the nut, and the fiber inserts were visibly worn and displayed the full thread form. Here's another one. This is a public use aircraft. During a forced landing, the throttle would not retard all the way and the airplane struck a pole. The bolt that normally connected the throttle linkage clevis, and remember I said they are used in some applications for both throttle and also with flight controls, was missing and allowed the throttle cable to disconnect from the throttle control arm. We also examined a sister airplane, revealing that a nut with a nylon insert had been installed on the clevis bolt and that it was loose enough to be removed by hand. And if you take a look at this, everybody goes, well, I don't see where that thing came undone. Well, this is a mechanic's way of going ahead and trying to fix the problem. So what he did was he actually put on some castellated nuts with a cotter pin with RTV silicone sealant on top because he wanted to make sure that thing was not going to ever come off again. So what can you do? Comply with instruction in your aircraft's applicable maintenance manual. And if there is no guidance on reuse of the nut, you want to go ahead and use FAA Advisory Circular 43.13-1B, and that'll be Chapter 7, Section 4, and confirm that the specified hardware is installed correctly. You want to ensure that adequate torque is required to spin the nut on the bolt, and be aware that binding in the assembly may produce a false indication of nut effectiveness. So even though you torque it down, if it's not installed correctly, you may not be looking at the actual torque you need. You want to throw out a nut that can be rotated on the thread by hand, and you want to ensure that sufficient thread protrusion exists. Don't ever run a tap through the fiber of the nylon insert, because doing so will remove the locking capability of the nut. Remember, like we said, its diameter is actually smaller than the actual bore of the nut itself, and that's how it gets its grip. And you don't want to use elastic nuts in applications above 250 degrees Fahrenheit, or the locking properties will be reduced because it gets soft. You don't want to use elastic lock nuts on threads with a cross hole intended for a cotter pin, because it will actually chew up the material on the inside that's designed to lock, unless it's specified by the manufacturer or it's a combination nut type, for instance, a castle with an insert. And remember, as we said before, when in doubt, you want to throw it out. So A lot of people will attempt to reuse it. My personal policy is that I just throw the nut out. They're cheap and they're inexpensive. I can always get more. Okay, let's talk a little bit about safety wire. There are many combinations of safety wiring with certain basic rules that are common to all applications. And believe me that this is actually an art form. Safety wire installation is fairly simple, but needs to be done properly to ensure proper security for the fastener in question. Now, we've seen all sorts of safety wire problems on accidents and incidents that we investigate, and everything from something that looks like somebody dropped a cat into a bowl of spaghetti to ones where they've done a very nice job, but it's too tight, and we'll talk a little bit about that. The safety wire should be threaded through the object fastener so that it creates tension in the opposite direction of the fastener's removal. For example, if a standard bolt in the U.S. is being secured, then the safety wire, when installed, okay, should put tension on the bolt in a clockwise direction. That's in the direction that the bolt turns to tighten. And just like with bolts, remember it's righty-tighty, lefty-loosey. All right. Safety wire must never be overstressed, okay, because it will break under vibration if twisted too tightly. And it must be pulled taut when being twisted and maintain a light tension when secured. That doesn't mean bar tight. It must not be nicked, kinked, or mutilated, and excessive twisting of the wire will weaken the wire. And the safety wire should never be reused. I've seen people do that before, and it always results in problems. Let's talk a little bit about related accidents. And this one happened to be a gold mine, so we're not going to do multiple accidents for safety wire. We're just going to talk about one of them. And if you take a look at the airplane, you'll notice that is not a prop modification on there, and that front gear door doesn't look normal. And if you walked up to the airplane, you go, oh, it's just minor damage. Well, what we don't show in here are the frames underneath that were damaged. So the airplane itself is actually substantially damaged. That's the engine out of the airplane. Everybody says, so what happened with this airplane? Well, the gentleman took off out of Elizabethton, North Carolina, ended up joining the downwind to go ahead and depart, and the engine rolled back to idle. So what he did was he ended up making a very tight right turn, was able to get it back on the airport property, and unfortunately he did not have time to get the landing gear down, but he got it down safe onto the grass near the runway itself, but unfortunately, as I said, the aircraft was substantially damaged. So here we have our engine. Looks like just like any other PT-6, with exception with a few problems. And what you're looking at right there is an arm for a manual fuel control unit. Does that safety wire look correct to you? If you take a look, you'll see a stop on the left side. That's where that threaded screw object is. And just below that, you'll go ahead and see a little piece of metal that it sticks out. And that's designed to limit the travel on the arm. Well, somebody ended up modifying this thing so that way if they use the manual fuel control, it wouldn't go to full travel. So if you take a look at it, that safety wire is not supposed to be in that position, and what it's doing is restricting the travel of the manual fuel control arm. What do you notice about this one? There is no safety wire. See the holes? They can come loose under vibration. It's supposed to be safety. This is on the same engine. Here's another problem with the engine. This is what caused our rollback. See the broken safety wire on top? That B-nut is on a PY line, and what happened was when that thing loosened up, the safety wire came off, and the torque backed off the nut, it dropped down to idle, and that's why he had no throttle control. Take a look at the safety wire on the left side. All right. If you put your finger on it or you touch that thing with a screwdriver, that thing's bar tight. All right. It's tensioned way too much, and that's the same thing that we found on the B-nut. The B-nut itself was tightened, the safety wire was tightened, and it had been nicked during the application process when they inserted it, and that allowed the wire to break. Here's another shot of that from the left side, and you'll notice that the hole is in the B-nut, and you'll notice that the safety wire is not connected. So things such as safety wire can cause accidents. So what can you do? Use the guidance contained in Federal Aviation Administration Advisory Circular 43-13-1B. And for those of you, if you're pilots like me and you're cheap, one of the beauties of this is the FAA puts this stuff all online. You actually don't have to pay for the manual anymore. You can print it out, or you can do it off a laptop or a tablet if you need it. All right. Once again, don't reuse safety wire. And you want to make sure that all safety wires are tight after installation, but not under such tension that normal handling or vibration is going to break the wire, as we saw with the B-nut. Twist should be tight and even, and the wire between nuts as taut as possible without over twisting. Okay, 6 to 8 turns per inch, and you want to put a pigtail of 1/4 to 1/2 inch, about 3 to 6 twists at the end of the wire. The pigtail should be bent back or under to prevent it from becoming a snag. Well, you don't just want to worry about the snag, you also want to worry about your A&P mechanic, because they do get very upset when you sit there and you start poking holes in their fingers. When castle nuts are safety, the nut should be tightened to the low side of the selected torque range, unless otherwise specified, and if necessary, continue tightening until the slot aligns with the hole, and the wire must be applied so that all pull exerted by the wire tends to tighten the nut. The wire should always be installed and twisted so that the loop around the bolt head stays down and doesn't tend to come up, causing a slack loop. When it does that, what ends up happening, it's no longer maintaining that tension. And most of all, you don't want to forget to buy the tools and practice. That's the other thing that we run into. Some guys are, they'll do it in art form, they do it by hand, all right? If you want to get consistency, you want to go ahead and use the tools. They're not that expensive. Let's talk a little bit about safety cable. For those of you that deal with OEMs such as Lycoming, Continental, and other manufacturers, you see more and more of this. And it's an alternative to safety wire. It's composed of strands that are helically twisted without a core. That eliminates the need for twisting during installation, as is required with safety wire. And it's becoming an industry standard due to easier control of critical inputs and reduced installation time. And if you've ever seen this, it's really slick. Installation quality requirements of safety cable are governed by SAE AS 4536. And that's it. Does anybody have any questions? Okay. Thank you.
Thank you very much for the presentation. Well, that was sort of quick. Does anybody have any comments, anything? I guess that's it. Thank you very much. And if you'd exit out to that door off to your right over here. Thank you. Enjoy sun and fun.